Section 11.5 here, we're going to look at areas of circles and sectors. Again, areas of circles is something that we've already discussed, which should be review for you. And then sectors is very similar to, relates to areas of circles, just like arc length related to the circumference of a circle that we saw in the previous lesson. So that's what we're looking at today. Very similar to the previous lesson. So a sector is very simply the region bounded by two radii of the circle and their intercepted arc. In other words, if I'm looking at this circle here and I draw in two radii, okay, yesterday we said, hey, this is arc length right here. Today we're looking at the area of this whole piece right here. Okay, so like a slice of pie is one way of thinking about it. And so the area of a circle is something that we need to review real quick beforehand. The area of a circle is given by the formula pi r squared. Okay, there's no secondary formula like there was for circumference. A equals pi r squared, where r is the radius of the circle. Okay, to find the indicated measure, we got to find the area of this circle. It's pretty straightforward. A equals pi times 4.2 squared. Okay, and again, let me just grab a calculator. So I have 4.2 squared. 4.2 times 4.2, that's 17.64 pi. So if I multiply 17.64 times 3.14, I get 55.39 meters, and again it's area, so it's meters squared. In part B here, they're asking us to solve for the diameter of the circle, and so there's no, because they give me the area, there's no direct way to solve for the diameter, so I have to first find the radius, and then I can find the diameter. So I know that A equals pi r squared. I know that A is 201 equals pi r squared, so I'm going to divide both sides by pi, and again I'm just going to use 3.14 here, so I have 201 divided by 3.14. If you have a pi button on your calculator, you're going to want to use that. I got 64.01, and so when I take the square root of both sides, the radius of this circle, let's see here, so I have the square root of 64.01. It's obviously just going to be 8.0006, so we're just going to round that to 8. Okay, so the radius here is 8 inches, which makes the diameter 16 inches. Okay, so again, you got to kind of go through the radius to find the diameter. And you guys can look at parts C and D, very similar to parts A and B, and we'll talk about those in class if we need to. Okay, so the area of a sector, you're going to notice this one sets it up as a proportion. So the area of a sector is can be set up by the area of the sector over the area of the whole circle, pi r squared, and then the measure of the intercepted arc, so the measure of arc AB here. All right. Another way of thinking about this, and obviously they don't have it on the notes here, but the other way to think about it, just like we did yesterday, is you think area of a sector equals the measure of the arc divided by 360 times the area. Okay, generally that's what I'll use, because again, the way I think about it is this expression right here, the measure of the arc over 360, tells me what percent of the circle I have, and then obviously I take that percentage and I multiply it by the whole circle. Alright, so it says find the areas of the sectors formed by RQS. There's obviously two sectors here, so we'll look at this first one here, that I just kind of outlined. So if I want to look at that area, okay, A equals, okay, now it's a sector, so again there's two ways of doing it. The way I would do it is I would say 63 over 360 times pi. Our radius here, I'm having a hard time seeing it. Our radius is 5, so pi times 5 squared. And then all I have to do is simplify this now. So when I do all of this and I plug it into a calculator, I get, let's see here, 63 over 360 times 3.14 times 25, and I got the area to be roughly 13.74. They don't tell us units, I don't think, so we'll just say units squared. Okay, and that's the area of that guy there. If I want to find the area of the other sector, okay, I could find the area of the whole circle and subtract, or I could just say, okay, A equals the measure. If I'm looking at this sector now, the measure of this angle here, I can find it. 360 minus 63 is 297. So I have 297 over 360 times pi 5 squared. Okay, and so now again, I just go to my calculator. 297 divided by 360 times 3.14 times 25, and I got 64.76. 64.76 units squared for the area of the bigger sector. Okay. So example B is the same way. So I would pause the video. I'm going to go through part B really quick, and then we'll kind of go from there. So for part B, the area of the smaller sector. Sorry about that. Evidently, my arm brushed the. All right. So A equals, I don't know what's happening there, guys, just kind of bear with me here. So A equals central angle over 360 times pi r squared. And again, at this point, I'm done. I'm just going to plug it into a calculator. So I have 106 divided by 360 times 3.14 times 9 squared is 81, and I get the area there to be 74.89 square feet. And again, that area is this blue region here. If I want to find the area of the red region, again, I got to find this angle measure now. So the area of the red region, the angle measure, that's 106. So 360 minus 106 is 254. So 254 over 360 times pi r squared. And again, I'm not going to mess around here. I'm not going to try to simplify on my own. I'm going to let my calculator do my work for me. So 254 over 360 times 3.14 times 81. I got 179.45. 179.45 square feet. And that's the area of a sector. And again, if you want to set these up using proportions, you can. For me, it's always just been easier to say area of the sector equals arc measure over 360 times pi r squared. Okay. All right, use diagrams to find the area of circle C and the area of circle G. So these are working backwards now. So understand this. The area of, my goodness, I don't know what's going on here. Try this again. Alright, so let's see if we can get this. So the area of a sector equals angle measure, or arc measure really, over 360 times pi r squared. Okay, and then plug in, this is the thing I like about this formula, plug in what you know and solve for what you don't. They give you the area of the sector. This guy's 22 equals 45 over 360 pi r squared. Okay, so you can solve this a variety of ways. I want to get rid of this whole fraction right away, so I'm going to multiply both sides by 360 over 45. Okay, remember, to get rid of a fraction, multiply by the reciprocal, because 45 on top and 45 on bottom, 360 on top, 360 on bottom. So on the right-hand side, all I have left is pi r squared. On the left-hand side now, I have 22 times 360 divided by 45. I have 176. I want to get r by itself, so I'm going to divide both sides by pi. So r squared equals 176, and again, I'm just going to use 3.14. You can use your pi button and be more accurate. So I got 56.05. Whoops. And finally, I want r, so I got to take the square root. So the radius here is, let's see here, square root of 56.05. I got 7.49 for the radius. And remember, the question is find the area of the circle C. So the area of circle C equals pi times 7.49 squared. At that point, just plug it into your calculator. So I have 7.49 squared times 3.14, and I got the area of the entire circle to be roughly 176.15 square units, and our units are meters, so meters squared. That's the area of circle C. The second diagram is the same type of problem, so again at this point pause the video, kind of see where you're at here, and I'm going to buzz through it pretty quick here. So again, area of sector equals arc measure over 360 times pi r squared. I know what the area of the sector is at 6.4 equals 80 over 360 pi r squared. Multiply both sides by 360 over 80. So 80 and 80, 360 and 360 cancel. So the right hand side I have pi r squared. On the left hand side now I have 6.4 times 360 divided by 80, and I got 28.8. Oops. Divide both sides by pi, and again I'm just going to use 3.14 here. So I have 28.8 divided by 3.14, and I got 9.17. Square root both sides, so the radius here of circle G is roughly, let's see here, square root of 9.17, 3.03. And so then the area of circle G equals pi times 3.03 squared. And again now, let the calculator do the work for you. So I have 3.1, let me see here, actually I'm going to do 3.03 squared times 3.14. I got 28.83. Units squared. Units here are yards. Yards squared. So again, if you're using the pi button, you're probably going to be more accurate, so your answer is going to look a little bit different, but nonetheless you should be pretty darn close to that 28.83. Find the area of the figure below. So now this is a composite figure. What I mean by that is you'll notice you have two shapes here. You have a right triangle, right, which makes up this region, and then you have a sector, which makes up that region. You'll notice the sector is a semicircle. Okay, it's half of a circle. So the way I would do this is I'd say, okay, first of all, I want the area of, let's see if we can try to fix this again. All right. So we want area of the triangle, 1/2 base times height. The base of my triangle is 7. The height of my triangle is 4. So I have 1/2, 7 times 4 is 28, so I have 1/2 of 28. So 14 square feet is the triangle. Alright, and so now if I look at my sector, remember area of, there we go, area of a sector equals angle measure. So in this case it's a semicircle, so it's 180. So 180 over 360 times pi. Your radius here is 3.5 since the diameter is 7. Okay, and now again I'm just going to go to my calculator. So I'm going to do excuse me, 180 over 360 times 3.14 times 3.5 squared, and I got 19.23 square feet. And so now I got to take these two values, add them together. So if I do 19, let's see here, 19.23 plus 14, I get the area of the, let's see, I screwed that up, 19.23 plus 14, I get 33.23 square feet as the area of this figure.